Hello student, so let's go ahead with our session of software development life cycle. I am Dr. Alifia Jagridar, Assistant Professor of Abid and Amda Senior College. In this particular session, we are going to see what is verification and validation model. In short, it is also called as V and V model. It is one of the SDLC models. The V model is an SDLC model where execution of process happens in sequential manner in a V shape. It is also known as verification and validation model. Now V model is also known as extension of waterfall model, and it is based on the association of testing phase for each corresponding development phase. This means that every single phase in the development cycle will get directly associated to the testing phase. It is highly disciplined model, and the next phase starts only after the completion of the previous phase. That is the reason it is said that it is extension of V model, that is extension of waterfall model. Now if you see this diagram, as I just told you all, it is in the V shape, okay, and this is connected with each other with the phase called as coding. So under the V model, a testing phase of the development phase is planned parallelly. So there is a parallel phase where this is called as testing. So they all are integrated with each other, like requirement analysis related with testing phase, acceptance testing, then system testing, okay, architectural testing, integration testing, module testing, unit testing, okay, and it is in, if you see the diagram, this is called as V model, okay. So the verification phase is on one side and validation is on the other side. Both this phase are joined through the coding phase, okay. The V model or verification phase, there are different verification phases in V model, that is verification model. The first is business requirement analysis. This is the first phase in the development cycle where we understand the requirement of the customer through their perspective, okay, what exactly they are thinking. This involves detailed communication with the customer to understand his expectation and exact requirement. It is one of the most important activity and needs to be managed very nicely. If customer is not sure about what exactly they need, the acceptance test design planning is done at this stage, as business requirements can be used as an input for acceptance testing. Acceptance testing means you ask the customer, do you accept these requirements? Then only you go ahead for your further process. So acceptance test design planning is done at this stage as business requirement is there. The next phase is system design. Once you're clear with your business requirements, product requirements, it's now time to design the complete system. The system design will have understanding and detail of the complete hardware and communication setup for the product under development. The test plan is developed based on the system design. Doing this at early stage leaves more time for actual test execution. The next is architectural design. It is the specification where it is understood and designed in this phase. More than one technical approach is proposed, and based on technical and financial feasibility, the final decision is taken. The system is broken down into two modules, that is modules taking up different functionality. It is also termed as high level design, called as HLD, where the data is transferred and the communication is between the internal module with the outside world, that is other system, which is clearly understood and defined in this stage. With this information, integration test can be designed and documented during this stage. The next comes module design. In this phase, the internal design of all the system is specified, referred to as low level design. It is one of the most important that design is compatible with the other modules in the system architecture and external system. The unit tests are an essential part of any development process, and it is going to eliminate the maximum faults and errors at very early stage. These unit tests can be designed at this stage based on internal module design. Okay, so unit testing is done at this phase. That is called as low level design. Next comes coding phase. The actual coding of the system module is designed at this particular phase, where the best suitable programming language is decided based on the system and the architectural requirement. The coding is performed based on some coding guidelines and standards given by the companies. The code goes through numerous reviews and is optimized for the best performance before the final build is checked into the repository. So here the expertise person in the programming, the coder, will always keep on reviewing the code, and then the best is used for your final build. Okay. Next is validation phase. We have seen what is the verification phase. Now let's come to validation phase. In validation phase, there is a term called as unit testing. The first is unit testing. That means unit test is designed in the module design phase and are executed on the code during the validation. Means when you say that after a 3-click on my login screen, if it is unsuccessful, it will exit the login module and come to your website. So that is how I'm going to validate what you say. So unit testing is the testing at the code level, and it will help to eliminate the bugs at very early stage, though all defects cannot be uncovered by unit testing. Next is integration testing, where it is associated with architectural design phase, and it is performed to test the coexistence and communication of the internal modules within the system. How do they communicate with each other? System testing, it is directly associated with the system design phase. The system test will check the entire system functionality and communication of the system under development with the external system. Here most of the software and hardware compatibility issues can be reduced. Acceptance testing, it is basically associated with the business requirement analysis phase, and it involves the testing product and user environment. So you have to check your product in the user environment, and it will uncover the compatibility issues with the other system available in the user environment. Okay, it also discovers the non-functional issues such as load and performance defects in the actual user environment. Like for example, you are developing a software where you just consider of 100 records, but when it goes into the market, that is user environment, it may have thousands and millions records. So at that time it should give the same performance what we have committed. It should take the load correctly, and it should not reduce its performance or its efficiency. So here it is called as acceptance testing. What are the applications of VModel? It is same as your waterfall model, as both the models are sequential, because VModel is an extension of waterfall model. Requirements have to be very clear before the project starts, because it is expensive to go back and make the changes. This model is used in medical development field, as it is very strictly disciplined domain. There are certain pointers which you should keep in mind for scenarios to use VModel application. First of all, your requirement should be well defined. It should be clearly documented and fixed. Product definition should be stable. Technology is not dynamic, as it is well understood by the project team. There is no ambiguous or undefined requirement, and the project is short, that is small. The advantages: first is it is very highly disciplined model, and phases are completed one at a time. It will work for smaller projects where requirements are very well understood. It is simple and easy to understand and use. It is easy to manage due to rigidity of the model, because each phase has specific deliverables and review process. Disadvantages: high risk and uncertainty, not a good model for complex and object oriented projects. It is poor model for long and ongoing projects, not suitable for projects where requirements are at moderate to high risk of changing. And if once an application is in testing stage, it is very difficult to go back and change its functionality. No working software is produced until late during the life cycle. So these are the disadvantages and advantages of VModel. The next is Big Bang model. Now Big Bang model is an SDLC model where we do not follow any specific process. It just starts with the required money and efforts as the input, and output is the software developed, which may or may not be as per customer's requirement. Big Bang model does not follow any process, any procedures. Very little planning is required. Even the customer is not sure what exactly he wants, and the requirements are implemented on the fly without much analysis. Usually this model is followed for small projects where development teams are very small. Like, you can take it as a small project at your college level. So there you can use that Big Bang model. The Big Bang model comprises of focusing all possible resources in the software development and coding. Very little planning, or no planning you can say. The requirements are understood and implemented. Any changes required may or may not need to be revamped the complete software. This model is only for small projects with 1 or 2 developers, and is also used for academic or practice project. It is an ideal model for the product where requirements are not very well understood and the final release date is not given. Advantages: it does not require planning, it is easy to manage, very few resources required, it gives flexibility to developers. Disadvantage: very high and very high risk and uncertainty, not a good model for complex and object oriented projects, poor model for long and ongoing projects, and can turn out to be expensive if requirements are misunderstood. Thank you so much for watching my video. If you have liked the video, do press the like button and share and subscribe to the channel. Thank you so much.